Okay, now this is problem number 8 on some date. It gives you a rule for finding y prime. Negative variable a over 10 square root of y. For me, a is equal to 4, so a over 10 is 0.4, so this is negative 0.4 square root of y. The initial value of y, which I'll call y sub 0, is 200. And delta t is 10. Okay? And implicitly, y prime means the rate of change of y with respect to t. So you're going to, well, we calculate, first step in the algorithm. The algorithm says keep going a while. You can be more specific. Keep going for 10 steps. And there are ways that in different computer languages you make that happen, and we don't care about that. It's easy, very easy. I can generally read a high-level computer language. I was able to read the Pascal language and understood pretty much everything. I know I could just start programming. Okay? Yeah, it'll probably run into a couple of bugs, but it wouldn't take me 6 months to figure out what's going wrong because it's pretty simple. Now C++, which I've never bothered to learn just because by the time it came along, I didn't know how long my career was going to last, and I wasn't going to take 6 months to beat my head against the wall and learn all the ugly things C++ could do to you. And I never have and never will, I don't think. Okay? I know the theory. I'm satisfied. I can do everything I want to with a simpler computer language. And that's a digression on computer languages. But all I'm saying is these steps are easy to implement once you know the language and syntax of a computer language. And the simpler ones are really easy to learn. At least to do, basic stuff with. And then it always can get more complicated because algorithms can get extraordinarily complicated. It's the algorithms that are complicated, not the computer language. Computer language is much easier than learning foreign language. Okay. Okay, so anyhow, calculate y prime. That's your first step. Can we do that?
Yeah.
How are we going to do that?
Plug in.
Well, y is 200. We can plug in there, and boy, we didn't have any trouble doing that, did we? Okay, that's really easy. So, yeah, we do that. We calculate y prime. Now, I'm not saying put y prime in this register or put this in this register. I'm doing a kind of a higher level rather than a lower level algorithm here, okay? And we're not being specific about how to write algorithms. But down here, I go ahead and do this. And actually, I got that. Okay. Now, this says, so this might be where you had trouble. Anybody know what that really means? This is the way you write the delta symbol in HTML, but I forgot to convert this to HTML. Okay? I was a little careless with that. That's why I have to type it. But then I just put it in the HTML editor and it changes it. Or, if you put that into a text file that you then read through an Internet Explorer or Safari or Chrome or whatever, that's what Chrome sees and interprets. There's also a number you could put in there, a way to put in a hexadecimal number that refers to it. But it's much easier to remember the words and much easier to type them. Okay, so really, that was kind of my mistake. And if that was the problem you all had with this, then I certainly understand why you had a problem with it.
So that means delta y.
So this means, I did make a very good ampersand there, but this means delta y and this is not delta y, it's delta t. Okay? So this is the step. Now, can we do that step? Well, you can think of registers if you want. I mean, you got y prime in some register. So I could have said y prime goes into register Q, but I just said calculate y prime, and then y prime times delta t becomes delta y, right? Does that make sense? Do we understand why? It's because y prime is basically a delta y over a delta t. So that delta y is a y prime times delta t. Something we do want to kind of get used to. And then your next step should read, without the capital delta, this. Okay, can we do that? And we keep going. Okay? So the first few steps, okay, just call this step 1, 2, 3. Step 1, y prime equals negative 0.4 times the square root of 200. That's going to be like negative, oh man, that's going to be ridiculous. No, it isn't. 14 times 0.4, 5.6, something like that. That's probably 5.7 something. But we'll just say 5.6, it's an easy number. Okay, and that just comes out of this calculation, right? You put 200 in for y. Yeah, just to be so explicit. It's negative 0.4 times the square root of 200. I'll say negative 5.7. And then delta y becomes y prime, which is negative 5.7, times delta t, which is 10, which is negative 57. And in the next step, y becomes y plus delta y. Well, y is 200 plus negative 57, and that equals 143. Okay? So now we've done it, what do we do next? Well, we do steps 1, 2, and 3 again. Now y prime equals negative 0.4 times the square root of what? Well, it's going to be negative 0.4 times the square root of y. What's y? What's living in the y register at this moment? 143. See, we just did that, right? So that's 143. And that's real close to negative 4.8. Okay? And then in the second step, delta y will be replaced by negative 4.8, which is y prime times 10, which is, yeah, it is negative 48. Thinking ahead to the next step. And then y is replaced by y plus delta y. What's y? Well, last time we put something in the y register, it was 143, right? So y is still 143 plus negative 48, which equals 95. And then step 1, that's all I'm going to do now. Y prime is going to be negative 0.4 times the square root of 95. Okay? And that's approximately negative 3.5, probably. I'm pretty sure about that. Okay? Etc. And maybe this represents the depth in a container, and we stop when the depth stops changing. We stop when we get a positive value. Of course, we'll never get a positive value there. But we stop when we get a negative value of y because we can't take the square root. Okay? Anyhow, that's how it works. Right? So there's nothing particularly difficult about following these steps if you just know what the notation means. And if I maybe, write out, remember to run the thing through the HTML editor. Okay? Make sense? Before I print it. Okay? Because I just printed my code there. And then it says, sketch a trapezoidal approximation graph of y versus t and label the slopes and areas. Well, I didn't do anything with t here, but clearly if delta t is 10, implicitly every step t would increase by 10, right? Okay? Now I could do step 4. Which would have been a good thing to do, but I wanted to keep it as simple as possible. And if I did another one, I'd say that. And I could say t naught equals 0, okay? Then I'd have a step 4 where t equals 10 here, t equals 20 here, t equals 30 here. That's kind of implicit in the way we were doing the problem that day. It might have been a good idea for me to do that because it would have been easy. So I might have made the right decision or the wrong decision, but now we have t and we have y, and here's 200. So here will be 100. Here will be 150. So we start at 200. T goes 10, 20, 30. So we go down to 143, which is down about here. So that gives us a point here, 10, 143. And incidentally, when you do a graph, it's a good idea to label your points. And it's a good idea to do it accurately. That's 0, 200. This is 10, 143. This is 20, 95. And so on. So I ask you to plot those points. Well, that's easy. Everything here is easy. You just have to know how to read it. The calculations are not going to trouble you at all. It's the process that you're not familiar with that'll give you trouble, if anything does. Well, right there I've got a trapezoidal. I've got the start of a trapezoidal graph. Now, if I continue the algorithm, I'll probably get a point here, and then I'll get a point here, and so forth, right? And I'll have coordinates, and I'll be able to label the altitudes and the slopes, and the accumulated areas, and the rates of slope change, okay? And when I say label the trapezoidal approximation graph and don't say anything else, that means you do all that, okay? And having done all that, and of course I might say, and I did on problems that I gave you, you do a trapezoidal approximation graph for the normal curve, and just label the areas and accumulated areas, because that's all that really matters. Slopes don't really matter. Yeah?
Where'd you get the 10 and the 20 from? Like where it says 10, 145 and 20, 95?
Delta t is 10.
Okay.
That's implicitly the time,
so
right?
Changing. Okay.
So every time you do this, it's 10 seconds later. And that's why I was saying about the step 4 that I could have put in there but chose not to. I mean, I thought about it. Maybe I made the wrong decision. But then you would have values of t, and you'd have a step 4, so you'd have a value of t to put with it. But it's pretty easy to understand that t, in this case, would like go 10, 20, 30. Okay? Make sense? Okay. That's a start.